If you want to solve inverse problems, then you will need inverse pens. But first, what is inverse problems and how it is related to inverse pens? First, inverse problems are problems that involves determining the underlying causes or parameters of a system or process from observed data. So they will have the data, and you are trying to predicting what is the parameters that causes data. So this is the inverse problem. But now, how to do this solution? How can we get the data, or from the data, understanding or determining what is the parameters responsible about these data? Well, we use inverse pens, as I said. And inverse pens is an inverse physics informed neural network, which is a machine learning approach that combines neural networks with physical laws to solve inverse problems. It is used to infer the underlying parameters or properties of a system, which is the inverse problem. So it has many applications. One of the application of inverse pens is, for example, predicting the viscosity of a fluid, let's say in a Kalman vortex. A Kalman vortex is a phenomena that cause the flow to alternate as it flows around a buffed body, for example, a cylinder. Such phenomena is important as usually, let's say, in engineering, or in more specifically civil engineering, we don't like to have such flow around the building, as it might cause the building to vibrate or even collapse. So if we have the data or PIV data of the fluid, which is the particle image velocimetry data, in which we can see the flow movement and we can get the flow velocities, we can actually use these velocity direction in the x direction and in the y direction to actually build a model to predict, or build an IPENS model to predict the viscosity of the fluid, and later, of course, solve the whole system, that including pressures and any other parameters that we need to calculate, that the viscosity is a missing parameter to do it. In this course, we are going to learn inverse pens. We will start by first revising the general concept around PyTorch, in which we need to know how to code using PyTorch. After that, what we will do is we will compute the fluid phenomena using or a specific 1D Berger's equation using a finite difference method with a central difference scheme. We will find out that this scheme might not solve the Berger's equation up to a certain time domain, because of a discontinuity that might happen or that will happen, and then the solution or the solver fails. So we will use another method, which is the TVD scheme, to solve such method and build the data needed for training the inverse pens problem. After that, what we will do is we will use this data to actually solve the inverse pens problem, and we will compute the missing parameter. For example, in the Berger's equation, it will be viscosity. We will compare between the results of IPENS for a specific problem, the results of PENS, and even the results, of course, of TVD data. Followed by that, we will go a little bit higher regarding the equation complexity, and we will model the vortex problem, or the Kalman vortex problem, using inverse pens with application of deep XDE code. This way, we will calculate the viscosity of the fluid let's work together to learn IPENS, understand its theory, and get the skills needed to write our inverse pens problems using PyTorch as well as XDE.